So this is the first video for the core physics, and this is a specified practical that we need to know about, and it's likely this is going to come in. So I'm going to take a bit of time on this. So in the introduction there, the voltage across the current lamp of a component can be measured and the results plotted on a graph, on a current voltage graph. So that's what we need. We need a 12 volt filament lamp, we need a voltmeter, an ammeter, we need some leads, we need a battery or a 12 volt supply, and a variable resistor. Just worth noting, this is called the resolution of these voltmeters. That's to the degree of precision that it will measure in. So if you're ever asked about resolution in the prac exam, that's what that is. So the resolution here is 0.01. If we go down now, that's your standard circuit. So even though sometimes you see the ammeter on this side and the variable resistor on this side, this is your basic standard circuit. This is sometimes a resistor, and this is sometimes a diode, and sometimes a lamp. So there's three, and we've done all three. So I'll show you the video now of what I've set up. So this is pretty much the setup that we've got. This thing here is a variable resistor. We've got the voltmeter, which runs in parallel. There's the lamp. There's your power source, and there's your ammeter in series. So let me just pause this video a minute. So you can see here, the voltmeter is reading 6 at the moment. He's just started adjusting it up there. If I take that back, you can see it's in parallel because it comes off the battery. So the battery runs back to the power source. Then let me just try and take that back from the start, and then if I pause there, you can see, so it comes out into the ammeter, out of the ammeter, into the variable resistor, out of the variable resistor, into the lamp. Now the lamp goes back in, but you can see off that comes the voltmeter as well. And I just wanted to keep an eye on the brightness as well, because that's set to maximum. As he adjusts this down, so let's see him do that. As he adjusts it down, you'll see at the moment it reads around about 6 volts there. And this is around about 5 amps. But he's going to slowly start adjusting this now. So he's bringing that up. And the voltage is going to go up. I think I've asked him to go to 7. We should see the current go up slightly. You can see this bulb's getting brighter as well. And yeah, so it's gradually going up. And again, I've asked him to take it to 10. So he's choosing his increments there. And that's gone up to sort of... These things are not very accurate, which is why I'll show you this circuit view now. But you can see that's getting dimmer and brighter. So the variable resistance, just altering the resistance there. I think it's clearer if we get rid of that video a minute and pop it up there. Let's bring this one. I'll just show you what's happening here. So that is your basic layout, so of what I've just had. So you come from a battery. I mean, we came into the ammeter, but it doesn't matter as long as it's all in series. Come from a battery, variable resistor there. These things are going to move, and then you got your ammeter. Then we're going to put the bulb in there, and then back, and then off that bulb is going to be that voltmeter. So if I just press play on this, you see I've just popped the bulb in. Now, let me just press pause a minute. So what's happening now, I'm adjusting this, and for every 0.5, it's going to give me a reading. And what I do then, I'm going to plot that in like a table of results. So that's for the fixed resistor there. So let's put that there. I've got one for a filament lamp somewhere. So there's the bulb. Okay, and these are the results I'm going to get for this. So I'm just going to bring that over, and you can look at the results, and you can slow this down if you want yourselves, but I'm going to take this back. As I pop that bulb in, you can see if 0.51, 1.5, 2, so I'm choosing my voltage values, and the ammeter, I'm just taking the readings and plotting them and plotting them against my current. So I've actually turned the battery there. I should have pressed pause there. Let me just take that back again. You can see there's a point by here where I'm going to actually turn the battery to get some negative results. So I go back and turn the battery now, and now I'm going to start getting negative results. So that's what's written here now. And what that's going to look like in a graph for a filament lamp is going to look, if I just minimize this, I've got so many things open here now. It's going to look like that, where you've got that sort of, well, as X increases, as voltage increases, so does the current. So it's going up at a decreasing rate. So it's all fast, and then what happens is the bulb starts heating up, and it's going to be more resistance there, because as the particles get warmer, they start moving faster, and there's more collisions with each other. And if you've got more collisions, then there's more resistance. Okay, it's harder for that current to flow. So that's pretty much what the filament lamp looks like. If we go on to now, I think the next one I'm going to do is a resistor, a fixed resistor. And you can see, as I'm increasing this, same values again. I'm going to turn that battery, I'm going to turn it round. I'm taking these readings, okay, and then if I press pause and put that up here, I think my table of results for fixed resistor, that's for the 2 wires. For the fixed resistor is here. Now this is a fixed resistor at constant temperature. So if it did start warming up, you start getting that curve. But this thing is going to be directly proportional. You can see it's kind of the same every time. And you'll see when that's plotted, and there's my negative results there. When this thing is plotted on a graph, and I think there's my graph for that. So I'm just going to get rid of all that, get rid of that there. You can see that it's directly proportional. As this is 1, if this doubles, this doubles. So if I double that to 2, then that's going to be sort of 2.5. If I double it to 4, then if I move this, it's going to be around about that same doubling point. Okay, so it's all directly proportional. And again for the negative axes as well. Now I'm going to do it for a diode. A diode is a funny one. Interesting one. Bring that diode in. So you watch. So it takes a while. I don't know if you noticed there, but it took till I got to 1.5 volts to actually start any readings on that current there. And then watch what happens when I turn this battery now. So I'm going to take it back, and then I'm going to flip that battery. And remember, a diode will only allow current through in one direction, so it's not going to allow any current through in the other direction. That's why they're so useful. They turn alternating current into direct current, and you see them all the time, TVs and radios, things like that. And this graph is not that one. That's your filament lamp. That's your fixed resistor. It's going to look like this. There we are. Now the curve there, it's not the best curve. I got a student to do this. It looks like he's joined them up slightly there. Matthew, if you're listening, I do apologise. But what we want is that nice little curve going up. But notice that nothing on your negative axis. That's because it doesn't allow current to flow on that negative axis. I'm just going to put that up there. And then we've also got another graph here. Again, these have all been plotted in tables. So just before we do these graphs, we collected all these results. Thank you, Matthew and Mo, for that. But you can see here, I know that's upside down there, I can actually compare 2 metals. So let me show you the video of what I've done. I'm going to stick copper in first. Now I know copper is an excellent conductor of electricity and heat. It's because it's got free electrons, and it's just a really good conductor. You can see the values. When I get to 3.5, it's on 10.2 amps. I'm going to reverse that. I'm going to take the battery. I'm going to flip that battery, so I can get some negative readings. So I can go into the negative axes on my graph. So I got a really high value, but I'm going to stick another wire in, and you can see that it's not as high this time. Okay, so you do get good conductors, you get bad conductors. So let's just press pause and I'll show you the graph. And when we compare this now on a graph, the steeper the line, the more efficient that is at conducting current or electricity. Because if I take my voltage value, let's just go for 2 here. You can see that the nichrome wire is in blue, and for 2 volts there, I'm only getting just under 2 amps of my current. But for 2 volts in my copper wire, I'm getting 6 amps. So this has got a lot more current for the push. So this is what that makes this really efficient. So the steeper the line there, the better conductor it is. So the less resistance really. So the steeper the line, the less resistance it has. And you can also calculate that if you wanted to. You could take a value. You could take 2 there, and you could stick it so that you divide that by say 1.8 there, or maybe whatever it looks like. Every square here, because he's going up in 2s, every square is worth 0.2. So there's your 1, there's your 2. So whatever that value is, you could use Ohm's law, which is R equals V over I. And if you get confused with that, you can always use a triangle. And you can actually calculate the resistance. Now, we're coming up to 12 minutes. I just want to show you how this applies in a question. Because this is one of the questions that often comes up. And it says there, describe how you'd investigate how the resistance of a filament lamp changes with the voltage, including your answer, labeled circuit diagram, how you'd obtain a range of results, and how you would analyze these results. So I'm just going to bullet point everything I've said and everything I've done. There's my standard test circuit. Okay, I've got my battery, I've got my ammeter, I've got my bulb, because it's asking for a bulb. Sometimes it would ask for something else, but in this case it's asking for a bulb. And I've got my voltmeter to measure the voltage, obviously across the bulb in parallel. And I've got my variable resistor, which I've called a VR, to make it easier for me to write down. So the first thing I want to do is set my VR to the maximum setting. I don't really want to allow any current or voltage through the circuit. I want it to start at 0, don't I? And then I'm going to adjust that VR so that the voltage has got fixed values. For example, 0.51, 1.52, like I just did. I'm going to record the current then. I'm going to record that reading off there. And I'm going to put it in a table of results against my voltage. For every 0.5, I'm going to record my current. So that step really, repeat adjustments for VR to give a range of voltage current readings. For every 0.5, now I'm going to take my current reading, and I'm going to adjust it to 1, and I'm going to take a current reading, and I'm going to adjust it to 1.5, and I'm going to take a current reading. And then I'm going to plot those results on a voltage current graph, so a VI graph, or an IV graph, something it's called. You can also calculate resistance using that R equals V over I. So that is just the triangle would be V on top and then I and R. So voltage equals resistance times current. And I said there, note that the cell, you can turn that in the circuit to get negative values. And I've just sketched these, what it would look like. So a fixed resistor would be that straight line. The lamp would be like that curve. And then your diode would just be on that one axis, sort of in that positive quadrant of your graph. And that's pretty much it.